In today's note, we are going to continue to look at measures of spread. So again, measures of spread look at how spread out the data is, and it can tell you how similar or varied the values in your data set are, whereas measures of central tendency tell you the common trend. So again, we've talked about this before. We've looked at a couple measures of spread already in terms of the quartiles, the interquartile range, box and whisker plots. We have already mentioned range before, which was the highest minus the lowest value. And a new statistic that we're going to look at to help us analyze some of our data is standard deviation. And standard deviation tells you how spread out from the average your data is. So we know the average is our mean. It's a measure of central tendency. It tells us a common trend. The standard deviation tells us how spread out our data is from that average. And if we have a small standard deviation, that means our data is close together. A large standard deviation means our data is spread out. And we're going to look through the steps to calculate the standard deviation. And then we'll go into an example that looks at exactly going through those steps. So the first thing is we need to find the mean of all the values. And again, remember the mean is the average. So whatever our data set is, we need to find the average. We then need to find the difference of each data value, or the difference each data value is from the mean, or in other words, the value minus the mean. Then we need to calculate the square of the numbers in step 2, or basically the value minus the mean squared. Then calculate the sum of all the numbers in step 3 to get the total. So basically we're adding up all those numbers to get the total, and then dividing by the number of values. So almost like we're finding the average again. And then finally, we have to calculate the square root of our answer from step 4. And that will leave us with the standard deviation. It can help to use a chart to organize our steps, so that way all of our calculations, all of our data is organized so we don't forget anything. And again, we're going to go through an example and look at that. So in our example, the machine packaging cookies has been considered defective. The packages are labeled as containing 150 grams. A sample of 15 packages was selected and the masses are given. So we have all our masses laid out. So the first step, the first thing we need to do before we start going to the table is find our mean. So again, remember the mean is taking all the numbers, adding them up, and then dividing them by how many we have. And again, I'm not going to write that out, but we should find that our mean equals 150. The next step in our process is to do the value minus the mean. So that's going to be my second column here. And in order to help me do that, I'm going to write out all of my values in this first column here. So I'm just going to go back, I'm going to write out all my values. They don't need to be in order, so the order doesn't really matter here. So I'm just going to write them out as they are. Again, it does take a little bit of work. The math isn't too hard. It's more about just making sure you're able to follow the steps. So I have all my values laid out. So now I have to do the value minus the mean. So I'm going to take my value, so in this case 146, I'm going to minus the mean, which I found to be 150, and get my answer as -4. And I'm going to go through and do the same thing for every value. So 150 minus 150 equals 0. 152 minus 150 equals 2. And I'm not going to show the calculations, but again, it's the same thing all the way through. You're subtracting the mean of 150 from these values. If you get a negative number, that's fine. The final, or not the final step, but the third step is this next column where we do the value minus the mean squared. Or if you go back up to your steps, it says that in step 3, we square the numbers from step 2. So all of our solutions from the first, or from this first column here, we are going to square in the second one. And let me actually use a different color here. So what we're going to do, we're going to take -4 and square it and get 16. You take 0 squared, get 0. 2 squared and get 4. And the key thing, or one thing we want to make sure in this column, we want to make sure that there are no negatives. And there shouldn't be, because when we square a negative number, it should always be positive. So just make sure on your calculator you are putting brackets around the negative number. If you don't, your calculator may not consider that negative part of that square or part of the power, and in that case you may get a negative number. But all of our answers should be negative, because when we multiply a negative by a negative, which is possible when we're squaring something, it should always be positive. So 0, then 9, 16, 1, 4, 9. So you can see all of our numbers are positive. The fourth step is to add up all of these numbers. So we need to add up all of these numbers in this last column. So 16 plus 0 plus 4 plus 0 plus 9 plus 16 plus 1 plus 4 plus 9 plus 4 plus 16 plus 4 plus 4 plus 0 plus 9 equals, and we find all of those, we get 96. So that's part of step 4, because we found the sum, so we know our total equals 96. But what we then have to do is take the total and divide it by the number of values. So we have to do 96 divided by how many values we have, and we should count that there are 15 actual numbers, and when we do 96 divided by 15, we get 6.4. Then finally, in our last step, the last step is we're just taking the square root of the number that we just found in step 4. So the square root of 6.4 equals 2.52. So that means our standard deviation, or SD, equals 2.52. So after all those small calculations, we now have our standard deviation. So the next part of the question, the company determines that if any packages are more than one standard deviation from the mean, they are considered defective and cannot be sold. So what this means is I have, and let me highlight it, so more than one standard deviation from the mean. That's the key thing. So I know my mean is 150. That value of 150 is my mean. I know that if I go, or any one standard deviation from the mean is considered defective. I know what my standard deviation is. It's 2.52. So if I go one standard deviation or plus the standard deviation in the positive direction, I get to 152.52. But the one standard deviation could also be in the negative direction. So a minus standard deviation, because it's still 1 in either direction. I get 147.48. So what that means is I am looking for any values outside of 147.48 and 152.52. So by going back up and looking at my values, I can go through and circle which ones are below 147.48 and higher than 152.52. So that is one. That is one. There's another one. So those are all the values that are outside. So there are 6 values are defective. 6 values are defective, or 6 packages are defective, whichever way you want to word it. So then we come down to, do you think it's necessary to fix the machine? And I would say, based on what we found, yes. And because close to half of the packages are defective. So based on our standard deviation and what we're considering defective, the machine is spitting out packages where close to half of them are defective, and that's not really a good thing for a machine. So we can say that this machine needs to be fixed. And again, that's an example of standard deviation. Again, the math isn't too difficult. It's more about making sure you're following the steps correctly to figure out the standard deviation, which again is just a measure of spread. So again, make sure you know those steps. You can go back and watch this example of where we got the numbers from, how we figured it out, and hopefully you can get to the standard deviation.